Hello everybody, and welcome to the beginning of section 1.3. We're looking at page 19 of the workbook, and the topic of this section is the derivative at a point of a function. Okay, now derivative is a new term for us. Turns out this concept is one of the most important concepts in Calculus 1. Okay, so we're going to, in this preliminary video here, talk through what the derivative is all about. We can think of it graphically, and it's going to remind you of stuff that we've already talked about in the course. Okay, so we will start with the function f of x that we're given to the right here. And the first thing that they want us to do is to find the slope of the secant line that goes through the points P and Q on our diagram. Okay, so I'm going to start by finding the points P and Q and drawing in that line. Okay, we've seen this line before. Okay, and what they'd like us to do is to write down a formula for the slope of that line. Okay, so slope is about finding rise over run. Okay, so the first question that we could ask is, what's the vertical distance between P and Q? That would give us the rise, and we can see from our picture that that's just going to be the difference between f of a plus h and f of a. All right, so let's write that down and point out that that's the rise. Okay, and then the next question is, what would the run be? What's the horizontal distance between the points P and Q? Well, that's going to be the difference between a plus h and a. Notice that if you take a plus h and subtract a, you're going to get h, which in our picture is this horizontal distance right here. Okay, that is our run. So the slope then of that secant line is f of a plus h minus f of a over h. You might recognize that as the difference quotient that's come up a couple of times already in our course. Okay, now here's the next thing that's going to kind of lead us to the concept of the derivative. Okay, if you look down to the next paragraph here, we're going to let h approach 0. Okay, so in our diagram, what that means is that we're going to think of this distance h, this run, is getting smaller, which means that the points P and Q are going to get closer to each other. In other words, Q is going to move to the left if h gets smaller. So imagine shrinking the value of h a little bit. That's going to move the point Q over, and our secant line is going to look a little bit different. Okay, and if you make h a little bit smaller still, Q is going to get even closer to P, and our secant line is going to change again. Okay, so if you think of this as kind of a dynamic process, what we're asking is we keep doing that. We let h get smaller and smaller. What is the slope of the secant line approaching? And what we'll notice is if we draw in a tangent line at P, the line that just grazes it, the slope of the secant line is actually approaching the slope of that tangent line T. Okay, so we'll fill that in here. And you might recognize this process as something that we talked about in the last section. We're really taking a limit when we let h approach 0. Okay, so to put it all together then, this limit gives us, we could say it this way, the limit as h goes to 0 of the secant line slope is the tangent line slope. Okay, and because this limit comes up so often in calculus, we give it a special name. Looking down at this definition, it's called the derivative. Okay, the derivative of f of x at x equals a is by definition the limit as h goes to 0 of the secant line slope. Okay, one last thing to go with this definition. Because this comes up so often, we have special notation for the derivative. Our shorthand way of writing it is going to be f prime of a. Okay, that little apostrophe thing that I wrote there, we read that prime. I'm going to write the words over here. F prime of a. It's just a shorthand way of describing the derivative. Okay, and we'll make one comment before we close this video. So looking down at the interpretations of the derivative, remember that when you see this f prime of a, this derivative, it represents graphically the slope of the tangent line. Okay, so in the weeks that follow in the course, I'll be throwing that question out there a lot. What does the derivative represent? And I hope that that's the first thing that comes to your mind, that it's the slope of the tangent line. Okay, and then conceptually, you can also think of it as the instantaneous rate of change of a function. We'll talk about that more as well.